this video, we will cover a recurring board exam problem involving purlins. Now, although this is under steel design, yung analysis natin is medyo nagsaside pa rin sa mechanics. Kasi bending about X, saka bending about Y lang yung kinoconsider natin. So again, meron tayong bending about X, which is this figure. We are bending this about the X-axis, parang ganito. But usually, positive yung bending ng beams natin. Nakaganyan. Naka-mirror to. Kasi this is a negative bending kasi. And then, for bending about the Y-axis, ito yung ginagawa natin. So, magbe-bend yung beam pa ganito. About the Y-axis. Itong purlins kasi, subjected to bending about the X and Y-axis. So, it's important to be able to know how the beam would look like. But usually, we are considering I-beams or channels for our purlins. Now here, we have a light grade channel, and it is used as a purlin of a truss whose top chord is sloped at 3 horizontal to 1 vertical. Now yung slope defines this angle. Bale, 3 yung horizontal, so this is 3. And then the vertical distance is 1. So this is 1. And then we have here theta. Ito kasi yung itsura ng purlins natin. Ito yung trusses, tas naka-space yan. And then we have these purlins. Itong mga beams na nakapatong sa truss. Yan. Essentially, we are computing for this distance for our questions in number 1 saka number 2 because we want to find the safe spacing of purlins. But dito, makikita mo na merong sagrods. Now sir, ano yung sagrods? Itong naka-red, yan yung purlins natin. So for example, we have this channel, yan yung beam natin or purlin. This is how it looks like if we will try to draw it. But itong naka-red, that's still the purlin, but it's just drawn as a line for simplification. Now, yung sagrods, it will act as a support about the y-axis. Ito kasi yung mga sagrods natin. Yan. Nag-act siya as a support para sa weaker axis, which is yung y-axis. Yung IY kasi ng purlins, kasi di ba channel yung ginamit natin, it's significantly lesser than our IX. So sa IY, we need additional supports. But meron din cases na walang sagrods. Now we have the following properties. Sx is 4.88 times 10 to the 4th, and then Sy is 1.18 times 10 to the 4th. Now sir, ano yung Sx saka Sy? Recall that S is equal to I divided by C. Now diba, yung bending stress, Fb, is mc over I. Now we can take the reciprocal of this one such that we have 1 over S equals C over I. So essentially, itong C over I pala, pwede natin palitan ng 1 over S. So we have FB equals M divided by S. So we will use this para sa bending stresses. And then we are also given the weight. This is the weight of the beam or purlin. Now, hindi ko na draw dito, but this is our figure. We have a truss, and then we have purlins. Space natin. Ito yung top chord ng truss. These are the purlins. And then we have here the sagrods. And then we have L1, L2, saka L3. Now, these are all 2 meters. And then, di ba, yung spacing ng purlins yung gusto natin. So, we have this spacing. Yan. And then, sa side view, we have this figure. So, let's say this is, di ba, 3 vertical, 1 horizontal. Copy natin to. Now, aside from the weight of the purlin, we are also given the loads. We have roof loads, which consist of the dead loads and the live loads. So we have 1,200 PA, which is 1,200 Newton per m squared, and then 576 PA is 576 Newton per m squared. Ito kasi yung unit ng Pascal. Now we also have a wind pressure, which is 1.44 kPa. So this is Kn per m squared. Now for wind pressure, you have to account the coefficients. Now it varies when you're considering the windward side and when you're also considering the leeward side. Now here we have a wind pressure coefficient at the windward side of 0.2. So this induces pressure. So sir, ano yung ibig sabihin ng windward? So for example, you have this system, yung windward introduces pressure. So parang paganyan yung load niya. Now always remember that wind loads act perpendicular to the body. So that's why this is perpendicular to the purlin. So this is toward the purlin kasi nga diba, pressure yung nabubuo. But if leeward side, magbabago yung direction. Paganyan na yan. Kasi diba, suction yung nagaganap. So meaning, parang hinihila niya yung purlins mo. So magkaiba yung coefficients nila. Again, this is for suction. And then, for the windward side, pressure, it's toward. But this is essentially acting over the roof. Pressure kasi yan. That's force acting over an area. Yan. Erase natin. Now, we also have the allowable stresses. This can be used in our interaction formula. Now, for D plus L plus W load combinations, a 1/3 increase in allowable stresses is permitted. Now, this is important later. And so first, using 2 lines of sag rods, we have to find the safe spacing of purlins in meters due to dead load plus live load only. Now, it is mentioned that we need to only consider dead loads and live loads. So meaning, we have to exclude the wind pressure. So ito lang yung i-consider natin. But remember that the weight of the purlin is part of the dead load. So for number 1, we are only going to consider the weight, the dead load, and the live load. And so how are we going to analyze this? Let's take a look at this figure. Now let's say that this is, this is rotated. So this is now my y-axis, and then this is my x-axis. Diba, yung weight ng purlin, or the weight of any object, it has a component always acting downward. Wala naman kasing weight na paganyan yung itsura. It is always acting downward. So what we can do here is, it is mentioned that all loads pass through the centroid of the section. Now, the centroid of the section is somewhere here. So let's just say that we have this point and then we have the weight of the purlin. So this is gonna be W, which was, 71 Newton per meter. Yan. By the way, let's label this as theta. So theta, tan theta equals opposite divided by adjacent. So therefore, theta is arctan 1/3. We have 18.43. So we're gonna store this. Let's say, lalagay ko sa A. Yan. So theta equals 18.43 degrees. Nakastore yan sa A. Now again, we have the weight. And then we also have the dead loads and live loads. Now let's take a look at the dead loads and live loads. This is expressed as a pressure. Kasi it's force divided by area. Meaning, it actually acts over this area. But then, we're just gonna consider the tributary area. Now, ito na lang yung i-consider natin kasi this is a channel naman. So, considering this channel, parang ganito yung distribution ng load. Gamitan natin ng green. Parang ganito yung distribution ng dead loads saka live loads. Kasi yung dead loads and live loads kasi, those are all acting downward. Hindi yan perpendicular sa body. Yung perpendicular lang sa body is yung wind load. So this is acting downward. But we essentially just want its effect on the channel. Now, its effect on the channel is determined by the tributary area. Now, itong load kasi, sa buong roof kasi yan. Parang ganito. Yan. But we are just considering this channel. So, ano yung tributary area ng channel? We're gonna consider half of the 2 adjacent sides. So, its tributary area will be, let's use orange, it will be this area. Yan. Color natin. Ito yung tributary area ng purlin. Again, tig half ng adjacent sides. Now, would you agree that this is the spacing of the purlin? Yang distance na yan. This is S. Now, this is half of S. Yan. So, this is, S over 2. And then, this is also S over 2. Now, what is S over 2 plus S over 2? That's only the spacing. So, meaning, for the tributary area, yung width pala natin is equal to S. Again, S over 2 plus S over 2. And so, that's why, yung ginagawa natin, we want to reduce this into a uniformly distributed load acting sa purlin. So, if we are going to multiply the live load and the dead load by the spacing, we can convert it into a uniformly distributed load. So, ito yung mangyayari. Once mako-convert mo na yan, parang ganito na. Yan. And then this is now in kN per meter. Again, we are multiplying by S and not L kasi itong dimension kasi yung gusto natin. Multiplying this by S, itong distributed load, makukuha natin yung weight acting over the span. Hindi naman kasi ito yung ina-analyze natin, yung paganto na loading. We are interested dito. So then, we can say that the dead load is equivalent to dl multiplied by s, or simply 1,200 Newton per m squared multiplied by s. Now, diba, if you will multiply Newton per m squared by a dimensional unit, let's say meter, 1,200 Newton per m squared, let's say multiplied by 0.2 m, di ba, magka-cancel yung meter. Yan. And then we have meter at the bottom. So this is now Newton per meter, which is essentially a distributed load. So erase natin. And then the live load will also be LL multiplied by S equals still 576 Newton per m squared multiplied by S. Again, this is to convert it into a uniform load. Yan. Now, this is the cross-section of the beam. Now, if you will try to look at the side view, this is what we will see. Ito yung beam natin. And then, di ba, yung length niya is, saan na yun? Ito pala. Di ba, yung length ng purlin is this total length, which is, di ba, 6 meters. Ito yung purlin, again, ito yung purlin, ito yung top chord ng truss, which is, ito rin, ito yung top chord ng truss. Again, just refer to the figure. Ito yung truss, and then these are the purlins. So, we have here the side view of the beam, and then we have a uniform load, which is, diba, we have the dead load plus the live load plus the self-weight of the beam. Combination na kasi yan. And then, these loads are all acting downward. Now, what is DL plus LL plus W? Let's go back here. Now, dito, we have DL as 1,200 Newton per m squared multiplied by S. And then, we have LL as 576 Newton per m squared multiplied by S. And then, W is automatically 71 Newton per meter. And so, lahat pala, naka-Newton per meter. And then, again, this is 6 meters. But then, you have to account that what will cause a bending moment about the x-axis for this channel must be perpendicular to the section. Bale, we need the component of W that acts along the y-axis so that it will be perpendicular to our purlin. So, we actually need this component. Diba, this has a component acting along the y-axis. And then we can actually form a triangle. Now again, in forming this triangle, the hypotenuse must be W. Kasi yan yung original load natin. Yung original load always acts as the hypotenuse, and then the components will be along the rotated axis. So, we have here downward, and then we also have a horizontal component. Yan. Notice that the downward component of the weight causes bending about the x-axis. But it also has a horizontal component which will cause bending about the y-axis. Again, this defines the bending about y. So this will need a lateral load, while this defines bending about x. So this is produced by a vertical load. And so, we can label this as Wx, and then we can label this as Wy. Now, yung approach ko dito is, diba, this is W along x. Now, lalagyan ko yan ng y prime. And then, yung Wy naman, lalagyan ko ng x prime. Now, sir, ba't mo lalagyan ng y prime saka x prime? This is to indicate the direction of bending. Kasi diba, yung Wx, it causes this bending about y. So that's why I'm gonna add y prime, because this causes bending about y. And then for Wy, it causes bending about the x-axis. So that's why it's indicated here that it will cause bending about that axis. So I hope klaro. And so what is W? For W, let's just actually add these values. So move natin. Let's just copy this one. Ito na yung W. So this simplifies into 1,200s plus 576s plus 71. Or we can say 1,200 plus 576 multiplied by s and then plus 71. Yan. So this is W. Sabihin na lang natin W total. Now let's take a look at the angles. Diba, this is acting perpendicular to this line. Yan. Perpendicular yan. Now diba, this is theta. Yan, same lang yung slope niyan. So this is theta. And so if I'm gonna draw a straight line dito, pag ganyan, then this must be, let's say, alpha. So alpha is 90 minus theta. Now, if we extend this line, notice na this triangle, yung triangle na yan, is similar to this triangle, yung whole triangle. So meaning, we can get this angle. Now, this angle is just theta. Now, sir, bakit theta? Recall that this is perpendicular to. Yang angle na yan, perpendicular. Now, this is alpha. So, alpha plus theta, diba, that will total 90. So again, here we have alpha plus theta equals 90. Again, this angle is 90 degrees. So alpha plus theta, that's going to define this equation. And so if this is theta, this angle right here, then I hope you would agree that this is also theta. And so ito na yung gagamitin natin. Now, maybe the drawings were too small. Maybe the drawings were too small. You can actually write it right here para mas klaro. Let's draw a line parallel to the y-axis as labeled, and then let's draw a line right here. Again, this is theta. So this angle must be, diba, this is a right angle. And then considering this triangle, diba, this is alpha, or simply 90 minus theta. Now let's just use alpha. Now since this is perpendicular, then this is alpha plus theta. So theta is now inclined to the vertical axis. So that's how you can understand angles. So balik tayo. We can now solve wxy prime. So wxy prime is, we're gonna use, since this is our reference angle, we're gonna use sine to get this component. So we have wt sine of theta. And then for wyx prime, we have wt cosine theta, because this is the adjacent side to the reference angle. So wt cos theta, this will now define our loads. Now again, wxy prime causes bending about the y-axis. And then wyx prime causes bending about the x-axis. So now we're gonna compute the maximum bending about the y-axis and the maximum bending about the x-axis. Now, we have to take into account the number of sag rods. Now, we need to use 2 lines of sag rods. Now, let's take a look at the moment diagrams. We have the following figures. Now, this is applicable for no sag rods. Kasi diba, if there are no sag rods, then the maximum bending about the x-axis and the y-axis will just be the same, which will be WL squared divided by 8. However, if you have sag rods, diba, it will help the y-axis resist bending. Kasi diba, yung sag rods, nagsusupport kasi yan dito. Parang nag-a-add yan ng support dyan. This is from the sag rod. So that's why the moment will be lesser kung merong sag rod. So kung merong sag rods daw at L over 3, meaning you have added supports right here, then you're gonna use WL squared over 9 for the bending about X, and then WL squared over 90 for the bending about Y. Dapat kasi magkatugma yung dalawa. And so that's why, although ito yung bending about X, if you have sag rods at L over 3, yung maximum moment kasi dito sa merong sag rods na configuration, it's WL squared over 90, which is located at this point. And so dapat, dun sa bending about X, dapat aligned yung moment mo. And so when this is L over 3, then you have this value of the moment, WL squared over 9. However, if you only have one sag rod, then the location of the maximum moment is just at the center. So magtutugma yan dito sa WL squared over 8. That's why, if you have sag rods at L over 2, then you're gonna use WL squared over 8 for the bending about X, and then for the bending about Y, you're gonna use divided by 32. But again, for 2 lines of sag rods, you have to use WL squared over 90, and then yung katumbas niya is WL squared over 9. So this will define the maximum moments about the different axes. So copy natin to, lagay natin dito. So we have here, the maximum moment about X is gonna be W, which is, diba, ito, yan yung total weight, W multiplied by L squared. So this is gonna be 6 and then squared, kasi diba ito yung length ng beam, divided by 8. Ito yung maximum moment about X. Now about Y, by the way, this is about X prime and this is about Y prime. Now diba, what causes bending about X prime is WY. And so meron pang kulang to. We need to multiply cosine theta or sine theta to reorient the component. So this must be, since again, WY causes bending about the x-axis or x prime, then we have to use cosine theta. So cos theta, yan. Again, this is WXY prime. Now for MY prime, we have to use, this is 9 pala. Now sir, bakit 9? Again, we have to use 2 lines of sag rods. So, we have this figure. 2 lines of sag rods. Yan, yung dalawa. So, MY prime is WL squared divided by 90. So, we can still copy this. And then we have sine theta. multiplied by 6 squared, divide natin by 90. Yan. And so this is, this was wyx prime pala. And then this was wx y prime. Again, dapat magkatugma yung bending. X prime is to x prime, y prime is to y prime. Kaya mas maganda pag nilalagyan mo ng y prime saka x prime. Pero depende lang yan sa'yo. Now, diba, in our interaction formula, we have fbx divided by capital FBX plus FBY over capital FBY. This must be equal to 1. Now, sir, what is FBX and FBY? Yan yung bending stress caused by the following moments. Now, what is capital FBX and capital FBY? These are the allowable bending stresses. Now, diba, it was stated that the allowable stresses are the following. Equal lang, and then we have FBX and FBY equal to 207. However, we can replace FBX and FBY. I hope you would agree. And then, diba, FBX and FBY is in MPa. Now, what is MPa? Diba, that's equivalent to Newton per mm squared. And so, this essentially means that we have to convert everything, our moments right here, we have to convert it into Newton mm. So here we have, let's write down FBX. Now what is FBX and FBY? Again, for the bending stresses, if you are given S, or the elastic section modulus, then the bending stress will just be M divided by S. So copy natin. And then, let's also copy the values of SX and XY. And so, FBX will be this expression, this is the moment, and then diba, moment divided by S, since this is the bending about X, then we're gonna use SX. So over SX, again, this whole expression is MX, and then this is divided by FBX, which is, diba, 207 MPa. Now, this is already in newtons, so this is okay, but 6 is in meters. So we have to convert this into mm squared, since this is squared. So we have to multiply the numerator by 1000 squared. This is to convert m squared into mm squared to make units consistent. Now we have SX. SX is 4.88 times 10 to the 4th mm cubed. Yan. And then we're gonna add plus, we need FBY. So for FBY, we have this moment. So the moment times 1000 squared, and then divided by SY, we have SY equal to 1.18 times 10 to the 4th. Yan. And then this is divided by capital FBY, which is, diba, 207 pa rin. So, 207. And so, this must be equal to 1. So, equals 1. We can now solve S. Now, masyadong mahaba to sa calculator. If you will type this, medyo alanganin ka na sa oras. So, I will be teaching you another approach para ma-streamline yung process. So, diba, this expression is essentially unchangeable. Or, diba, these are constants. 6 squared over 9 divided by 4.88 times 10 to the 4th. And then, ito ring 1000 squared. And then, for this one naman, 6 squared over 90, and then 1.18 times 10 to the 4th, saka 1000 squared, that's also a constant term. And so, yung gagawin mo, essentially, is to, parang magko-consider ka ng unit normal load, saka unit tangential load, using the following. Parang, gagawin mo itong 1, and then this expression, gagawin mo ring 1, and then, just get the constants. So, ito yung mangyayari. Input mo yung 6 squared over 9, ganito, 6 squared over 9 over 4.88 times 10 to the 4th, and then times 1000 squared. So, press equals. To store natin to sa B. So, shift store, lalagay ko sa B. So, this is now stored at B. And then, ito naman is to store ko sa C. Now, sir, bakit di mo pinapakialaman yung A? Kasi diba, yung A ko is yung angle theta. Yan, 18.43. And so, 18.43, and then yung sa C, lalagay ko 6 squared over 90 divided by 1.18 times 10 to the 4th multiplied by 1000 squared. So, I will store this dito sa C. Yan. And so, yung mangyayari, ito na lang yung ika-copy ko. So, we have this, and then divided by 207. This one. But, itong naka-gray, it's already stored into B. So, I'm gonna multiply this by B. And then plus, copy ko to. This is divided by 207. And then, I'm gonna multiply this by C. Yan. Equals, diba, 1. So, dito sa calculator, gagawin ko, 1,200 plus 576 multiplied by S. That's my unknown. And then, cosine theta. Again, theta is stored into A. Lalagay ko na lang. This is divided by 207. And then, plus 1,200 plus 576 times S plus 71. By the way, this must be in a parenthesis, yung buo. So, until we still have plus 71. Cosine theta over 207. And then, 1,200 plus 576 times X plus 71. Lalagyan natin ng parenthesis. And then, sine theta, which is again stored into A, divided by 207. Now, itong pag-store dito sa B sa C, you want this to be your first step. After identifying the maximum moments, lagay mo na lang to. Bale, kunin mo na yung FB agad. And then apply M over S or MC over I. Sa ibang problems kasi sa Purlins, hindi kasi S yung binibigay. Minsan, binibigay yung section mo. Let's say, yung channel, bibigay yung depth, and then ibibigay din yung moment of inertia. So, kung given yung moment of inertia saka depth, yan yung gagamitin mo para sa C over I. So, depende na rin yan sa diskarte mo. And so, essentially, if you're given C over I, just include everything excluding this expression. What defines the load? Now, yung coefficient ng moment saka yung S or C over I, ito, gawan mo ng paraan na ma-store mo sa calculator. And so, this is multiplied by C. So, times C, this is gonna equal 1. By the way, dito pala, nakalimutan natin i-multiply sa B. So, times B. So, press Shift Solve. And then solve for X, try to input a realistic value. Now sir, paano malaman yan? Check mo yung choices. Now dito sa choices, we have 1.2, 1.4, 0.85, and 1. Now what is the approximate average of these values? Sabihin natin na it's around 1.25. Sabihin lang natin. So press equals. By the way, meron pa tayong kulang. Itong S, di ba? This is expressed in meters. Kasi di ba, this was Newton per m squared. So, review natin. Dapat, this is only multiplied by 1,000. Kasi di ba, if the load is Newton per meter, Newton per m squared, this is in PA. Multiplying this by meter, we have Newton per m. This is now the weight. And so when we will multiply this by L squared, the expression L squared, which is 6 squared, then we have times M squared. Now, M will cancel, and then our unit of moment will be Newton meter. Now, we don't need to convert Newton, only meters. So that's why we need to multiply this by 1,000 para maging Newton mm, so that it will be consistent with the unit of MPa. So change this one, this must be 1,000, saka ito rin. So, review natin yung mga nakastore. Again, A is 18.43. This is the angle theta. And then B is this expression, yung naka-gray. So, we have 6 squared times 1,000 divided by 9. And then, just multiply this dito sa 9. Kasi diba, we are just dividing this expression by S. So, we have times 4.88 times 10 to the 4th. We have 5 over 61. So, shift store, lalagay ko sa B. Yan. And then, this expression naman, I will store this sa C. So, I have 6 squared times 1,000. Divide ko yan by 90, multiplied by S. So, 1.18 times 10 to the 4th. Press equals, we have this value. So, shift store, lalagay ko sa C. So, I will now input this. So, I have 1,200. By the way, lagay mo to inside a parenthesis kasi we are multiplying this expression by S. So, 1,200 plus 576 multiplied by S. So, times X. And then plus 71. This whole expression is multiplied by cosine theta. So, cos of A. Yan. And then, divide natin by 207. So, over 207. And then, multiplied by B. Ito. And then, we have plus. Lagay natin to, 1,200 plus 576 pa rin, multiplied by S, and then plus 71, and then we have sine theta. Divide natin to by 207, and then multiply natin by C. So, times C, this is equal to 1. So, press Shift Solve. Again, lalagay natin dito yung realistic value, let's say 1.25, we have this answer. So solving S, we get 1.277. This is meter. And so let's check the choices. In our choices, we have 1.2, 1.4, 0.85, and 1.0. And so, ano yung pipiliin natin? Recall that in our concept of spacing, di ba, mas closely spaced yung purlins, mas magiging malakas. Kasi di ba, if they are closely spaced with each other, then mas magiging compact. So, yung gagawin, basta spacing yung tanong, you will actually round down. Again, the lesser the spacing, mas magiging magkadikit yung purlins. The larger the spacing, magkalayo na kasi sila. So, this is unsafe. This provides a more conservative design if you will round down the spacing. So, this now becomes 1.2. And so, our answer for letter A is, number 1 is letter A. Yan. Now, for number 2, using 2 lines of sag rods, find the safe spacing of purlins due to dead load plus live load plus wind load on the windward side. Now, let's try to check the windward side. For the windward side, we have a coefficient of pressure equal to 0.2. So, we're gonna use 0.2. And then, let's try to analyze wind loads. Now, diba, earlier, when we defined loads due to weight or dead loads and live loads, it's acting downward. However, kung andyan ka na sa wind loads, it acts perpendicular to the surface. Parang ganito. Ito yung itsura ng wind load. Now, since this is already perpendicular, then if we'll try to check the section, this is our channel, hindi na tayo magko-component. And then, diba, the wind load is perpendicular to the surface. So, ito yung itsura ng wind load. So, sabihin natin na this is W, let's just say W, this is on the windward side, so W, wind load for the windward side. Now, yung W, again, di na natin kailangan yan i-component because this is already perpendicular to the surface, meaning it already causes bending about X prime. Now, yung dapat mong tandaan is wind loads do not cause bending about the Y-axis, only about the X-axis. So, lagay na lang natin, causes bending only about the X-axis. And so, essentially, di ba, yung magbabago lang is this expression. Hindi na natin to papalitan, yung my prime. So, balik tayo dito. It's also indicated here that for D plus L plus W load combination, a 1/3 increase in the allowable stress is permitted. So, what is the implication? Bale, diba, our allowable stress is 207. Now, it is permitted daw to have a 1/3 increase in the allowable stress. And so, what is a 1/3 increase? Let's say we have 207. If we'll increase this by 1/3, diba, we're gonna add plus 1/3 of 207. And so, essentially, the new allowable stress will be 207 plus 207 divided by 3. So, it's gonna be 276. Yan. But, to make it more efficient, instead of using this, instead of computing this separately, we know that this is multiplied by 1 times 207 plus 1/3 of it. Now, 1 plus 1/3 is 4/3. So, we can actually permit 4/3 of 207. This is usually what is used. Now, this is in the denominator. Kasi diba, yung 207 is nasa denominator. And so, if we will multiply this by 4/3, again, this expression, 4/3, then diba, this is just the same with multiplying the expression by, since this is in the denominator, we can multiply this by 3/4 instead. But 3/4 is, diba, 0.75. Yan. And so, let me just copy this one. Bale, remove ko na lang to. For D plus L plus W combination, ito yung bagong expression natin. We need to multiply the whole expression by 0.75. Now, let's just use this one since this is the shorter approach. So, we have to multiply this whole expression by 0.75. But, again, we need to account the new load, which is the wind load. And then again, the wind load, this one, let's just rewrite it. We have a wind load acting perpendicular to the surface. So, this is WW for windward. And so, this directly causes bending about the X-axis. And so, what's gonna change is this expression for D plus L plus W. We have to add something to the bending about X. Now, what is the wind load? The wind load is expressed in kPa. So we have 1.44 kPa. Now, the tributary area of the wind load is still the same as the tributary area of the component of the weight. And so what we're going to do is we need to multiply the wind load by the spacing. And then we shouldn't put it inside here because we don't need to take its components. And so for the wind load multiplied by S, we're not going to multiply it by cosine theta because again, this is already perpendicular to the channel. And so what's gonna change is, let's just move this one, and then we're gonna add the wind load, the effect of the wind load. Now what is 1.44 kPa? 1.44 kPa is Kn per m squared. Now to make units consistent, we're just gonna divide this by, multiply, since 1 Kn is 1000 newtons. So this will cancel, and then we have 1440 Newton per m squared. And then we're gonna multiply this by the spacing to convert it into a uniform load in Newton per meter. And so just add plus 1440 multiplied by the spacing. Now, what's gonna account for the bending stress is still the expression B. So this is what's new, 1440 multiplied by S. However, do not forget the coefficient because we have a coefficient of 0.2 for the windward side. So here, you still need to multiply this by 0.2. So let's just move this. Multiply natin to by 0.2. Again, this is the wind load coefficient. Wind load coefficient. And then, yung nagbago rin is itong 0.75. This is due to the 1/3 increase in the allowable stress. Yan. And so if we're gonna type this, we can now solve S. So we have 0.75. This is multiplied to the whole expression. So 0.75, and then we have 1200 plus 576 multiplied by S plus 71, and then cosine theta, we're gonna add plus 1440 times S multiplied by 0.2, and then we have divided by 207, so 207, and then multiplied by B, and then we still have plus, again, 1200 plus 576, this is multiplied by S, and then plus 71 sine theta, so sine of A, divided by 207, and then we're gonna multiply this by C, so times C, and then this is equal to 1. So shift solve, press equals, and then solving for X, let's check the choices. Now in the choices, we have 1.85, 1.4, and 1.2. Again, I'm gonna input 1.25 as the realistic value. So press equals, we're gonna get 1.492. So here we have S equals 1.492, and then we're gonna round down, so this becomes 1.4 meters. Yan. So we have letter C. Now, let's try to solve number 3. Compute the total flexural stress due to dead load plus live load plus wind load. But this is now on the leeward side. Now, for the leeward side, we have a coefficient of 0.6. Now, take note that for the leeward side, what happens is suction. And so what's gonna happen here is, for the leeward side, we have WL, the direction of the force is actually away from the channel. So this will essentially cause a negative bending. Negative bending if we are on the leeward side. And so what are we gonna change? Let's copy this. And then for the leeward side, we have a coefficient of 0.6. So this is 0.6, but this is gonna be negative. So minus 0.6. Again, this is negative due to suction. Yan. And then for number 3, we actually want the total flexural stress. And then we are given the spacing. We have 0.75. So S equals 0.75. But we're only interested in the total flexural stress. We don't need to use the interaction formula. So we're just gonna remove this 207 and also this one, because essentially in this question we only want FBX plus FBY. This is the total flexural stress. Yan. So we won't equate this to 1, and then S is 0.75, so we will just change S. So here we can just modify this a bit, and then again, a 1/3 increase in allowable stress will not be necessary because we are not talking about the allowable. we are just only interested in the total flexural stress. So we will remove this one, and so we're just gonna input this. This is FBX plus FBY. This corresponds to FBX, and then this is FBY. Yan. So we have here, let's remove 0.75, and then to speed up things, let's just change 207 into 1 so that it will be disregarded. And then this is also 1. And then we're going to remove this. And then take note that what changed is the wind load coefficient. So it is now minus 0.6. So we have minus 0.6 instead of positive 0.2. And then press equals, you're going to get 135.09. By the way, X is 0.75. So this is 0.75. This is also 0.75. And also this one, 0.75. Yan. So press equals, times. Press equals, we have 71.023. So FBX plus FBY equals 71.023, and then this is MPa. Yan.